Okay guys, recently one of you, after watching a video that is moment frame versus brace frame, have asked a question that if there is a big technical structure where there is many equipment and they are mainly supported at the top tiers of the frame, in that case definitely they will have vertical loads, frictional load and bundle pull for exchangers. Okay, I am highlighting this one because that will be cleared in a few minutes. So bundle pull for exchanger, in that case how to determine whether moment frame is suitable or brace frame is suitable. Okay, so basically in this video if I discussed about the structural aspect and the forces that need to be remembered when you are designing an exchanger building. Okay, so in that case I think this question will be answered. So if you're new to this channel, please do subscribe and also don't forget to press the bell icon so that in future you can be benefited. Okay, that's a very fast. What is an exchanger building or what is an exchanger? So exchanger or heat exchanger is simply a tool that is used in refineries or process unit to cool down the process or cool down the refinery. So you can say that heat exchanger simply uh, exchange the hot air or the hot liquid or the hot fluid with cold one and keep the whole process or the system in a normal temperature. Okay, and this is an exchanger, you can see, and within this cell you can see that they are simply a bunch of pipes, okay, or a bundle of pipes that are inserted within this cell, and this cell structure is actually known as exchanger. Now this exchanger normally installed on ground because it's really heavy. Not only that, it produces lots of lateral load. How? Well, in the next slide I will discuss. So due to this huge lateral load and vertical load, normally these exchangers are installed over the ground. But in some cases, due to the uh, piping department requirement, you need to install them over the floor. Okay, or in some cases you need to build a separate exchanger building, particularly for these exchangers. Okay, so here you can see this is a typical exchanger building. Here you can see that at the top floor we have a massive exchanger. Okay, so now what are the forces that are coming due to this exchanger? One force is very clear, you will have some gravity load or vertical load. Okay, and also as you can see here that as it is anchored here. Okay, so go back to the previous slide. Here you can see that as they are anchored here and here, and you have some pipe that is coming from here, okay, then going into this exchanger. So due to this piping also you will have some anchored load and pipe friction load. Okay, so you can visualize this vertical load and some amount of lateral load due to the pipe friction. Okay, so lateral load, this pipe friction load or anchor load is very negligible for exchanger. So what is the actual magnitude of lateral load and why this is coming? This is coming because of the bundle pull extractor. What is that? Well, as you can see here that inside this exchanger there is lots of pipes or bundle of pipes. Okay, and after certain time period, what you need to do, you need to simply pull out all these pipes from this cell. Okay, and you need to clean them, then again reinsert them within this cell or exchanger. So during this extraction, here you can see if this is fixed, to extract this huge massive bundle of pipes, you need to apply a large amount of lateral force. As a result, you also apply the same reaction force to the structure. That is why during the extraction of the bundle, or here you can see that she has mentioned about the bundle pull for exchangers. Okay, so during this bundle pull for exchanger, you produce a huge lateral force that need to be encountered in your design. Okay, So we have mainly vertical force, then lateral force, and this lateral force is mainly due to the bundle pull process. Here you can see that in this massive exchanger building we have an exchanger here. Got it? Now this bundle pull extractor, this is the bundle extractor, this is the equipment which is used to extract this bundle from the exchanger, that is being used to extract the bundle. So during this extraction process, definitely there will be a huge lateral force. Now how to transfer this vertical force as well as the lateral force? Okay, so let's say you have a frame like this, you have vertical load like this. So definitely to make this stable, you can use moment connection to this frame. Okay, and also if you have a lateral load, okay, in that case also you can use moment connection, okay, to make this frame stable. But the problem is, in case of a moment connection, due to this lateral load, there is a huge deflection, lateral deflection. Okay, so due to this huge lateral deflection, what you need to do, you need to provide some bracing, because the lateral rigidity of a braced frame is much higher. So here delta is almost negligible, correct? And this lateral drift is very negligible, or the requirement of lateral drift is almost negligible in case of a process unit. Why? Because there are many instrument or many piping system, they are very closely located. So if you allow your structure to drift for this much value, let's say, maybe there is some another process unit, so they will collide. That is the reason we always want in our process industry that our lateral drift is negligible, it is almost zero. That is why we need to ensure that our lateral rigidity is much higher. Okay, so to carry this exchanger, maybe that your moment connection is sufficient to carry the lateral load that is coming due to the bundle pull extraction. Okay, but to minimize the lateral drift, I prefer at least we need to provide a bracing like this. Now look at the bracing in the exchangers. Okay, so here you can see that this is the exchanger. Okay, now of course when you will pull out the bundle like this, in that case the lateral load will be applied first in this beam. Okay, well, let me clean this one. Well, so this is the exchanger, and if we draw this plan, let's say this is the plan. Okay, let's say this is one support of the exchanger, this is another support of the exchanger. Okay, this is the plan view. Now when we are extracting the bundle, what will happen? There will be some lateral reaction, lateral force like this. So what you have to do, first you have to transfer this lateral load from this main beam or transverse beam, otherwise this transverse beam will buckle easily as the bending is being occurred about the minor axis. Okay, so to transfer this lateral load, what you have to do, simply you have to put a bracing like this. This is the plan bracing. I am talking about the plan first. Okay, so now this lateral load has been transferred from this particular point to this point and this point through this plan bracing. Now our beam is safe. This is the trans beam or the stringer beam or the main beam, whatever you can call it, doesn't matter. So the beam is now safe and we have transferred this lateral load successfully to this nodal point, or here this nodal point. This is the nodal point. Okay, now if you come to this elevation here, so we now have lateral load here and here. This is the support. So now to transfer this lateral load, what we have to do, we have to simply put another vertical bracing like this, and that is the reason here you can see this is the vertical bracing we have put. Clear? Okay, now come to this another example. Okay, first let me clean this one. So here also, as the exchanger is facing like this, and it will have a bundle pull force, extraction force in this direction. So we need a bracing in this direction here. Here you can see they have already put a bracing like this. This bracing is clearly visible, but here due to this large diameter pipe, it is not visible. But here is also there is bracing, and also on that side here you can locate the bracing. This is one bracing member, and this is another bracing member. So these bracing members has been put due to this lateral load only. Now you can ask why this bracing member has been put. Here you can see there are lots of piping arrangement. So due to this piping arrangement, of course there will be some anchor force as well as frictional load. So to carry this anchor and frictional load, we also need to put some bracing arrangement. Not only that, as you can see here, that this whole system is simply acting like an wall. When the wind is coming from this direction or earthquake is coming from this direction. So in that case, this huge mass create a huge lateral load in this direction. To carry this one, we need this setup of bracing. So that's it. There is no hard and fast rule. You just need to first find out what are the forces coming and in which direction. Based on that, you have to manage your connection type or your frame pattern. Okay, so that's it. If you love this video, don't forget to share it.